Let's recap what we had so far, specifically for the square lattice. So if we have a square lattice in real space, this looks something like this. So a 2D periodic structure, and the lattice constant is A, let's say. And then we know that we can associate in K-space a reciprocal lattice to that lattice, and that lattice also turns out to be a square lattice, but this time with a different lattice constant, namely 2 pi over A. And then last time we also said that we can reduce this entire K-space to a subset, the so-called Brillouin zone, which will then give us all the other regions of K-space simply by copying and pasting this Brillouin zone. So this is by exploiting the periodicity. So if you center this around, let's say, the origin over here, then the Brillouin zone also has side 2 pi over A. Okay, so that's just exploiting the translation symmetry of the system. Obviously, if you look at this 2D lattice over here, there's many more types of symmetries. For example, if you take this square lattice and you rotate it by 90 degrees or 180 degrees or minus 90 degrees, you end up with the same structure. Also, there's mirror symmetry along the diagonal, for example. Okay, I have some trouble showing that here. So if you have the diagonal over here and you flip the structure, you also end up with the same structure. So there's many more symmetries in this crystal than just the translation symmetry. And by the way, the collection of all of these symmetries is called the point group of the crystal, but that's just a piece of terminology here. What is of interest to us is that the fact that these extra symmetries are present will also mean that the square Brillouin zone that we've drawn here can actually also be made smaller. And more specifically, we can make it as small as this little triangle here, so like 1/8 of the Brillouin zone. And then you see if you take that triangle and you apply all of the extra symmetries that are present in the crystal beyond the periodicity, then you can basically fill out the entire original Brillouin zone. So if you start from the little triangle and then you flip it along the diagonal, you end up with 1/4 of the Brillouin zone, and then you just rotate it 3 times and then you fill up the entire Brillouin zone. So the name of this smallest structure inside the Brillouin zone is called the irreducible Brillouin zone. So it's just what you end up with if you take the Brillouin zone and you apply all of the extra symmetries that are present in the system. By the way, don't get confused. Some people say, okay, I have my little triangle over here. That triangle in the irreducible Brillouin zone has some extra symmetries. For example, I can reduce it by half here because it's symmetric mirror symmetry along this axis. That's of course true strictly for this triangle over here, but this mirror symmetry along this axis is not a mirror symmetry that's present in your actual crystal in real space, right? So don't get confused. Only exploit symmetries that are actually present in your real crystal, not in the shape that the irreducible Brillouin zone ends up having in K-space. Okay, that's just something you need to be aware of. By the way, this little triangle in K-space for our square lattice, the corner points here, they have special names. So the origin of this irreducible Brillouin zone is called the gamma point. So that's the 0 point in K-space. And then this point over here is called the X point. And this is the M point. So gamma X basically is a direction from the origin to the nearest neighbor. And there's in essence many more directions than just the one that I have here, because you also have, of course, the direction up and the direction left and the direction right. And then the gamma M direction, if you look back in the original real space, is not nearest neighbor direction, but the next nearest neighbor along 45 degrees here. So this is just what the irreducible Brillouin zone looks like for the square lattice, and naming conventions for some high symmetry points of that irreducible Brillouin zone.